Everything is good. So I'll just give an introduction to our organization and then we'll give an intro to you and then you'll have the chance to present the screen. Good evening, everyone. A very warm welcome to all of you on behalf of ISRO Space Tutor KIYE Foundation. This is Madhurima, your host for the day, and also I'm a part of Kalam's Institute of Youth Excellence, and I'm delighted to welcome you all to the 7th lecture of S Talks. We have already completed 6 talks successfully, and this is the 7th season now. So this is all related to space, aerospace, and futuristic technologies. To everyone joining us live on YouTube from across the country, welcome you all. We're so glad to have you with us this evening. And before we begin, let's make this session interactive right from the start. And if you're joining us live on YouTube, drop a quick hello in the chat and let us know where you're joining from. We would love to see participants connecting from across India. And that's the beauty of S Talks. Students, educators, professionals, and institutions from all over the country coming together with one shared goal: to learn, explore, and to grow. And that truly reminds us that curiosity for space and technology knows no boundaries. What makes this journey even more special is that it continues every single Saturday. Every Saturday, we come together to learn something new, connect with experts, and grow stronger as a community. Because the more we connect, the more we stay consistent. And consistency creates impact. S Talks is not just a lecture series. It is a platform, a community, and a mission. Inspired by the vision of Dr. APJ Abdul Kalam sir and his deep commitment to nation building, S Talks aims to ignite curiosity, inspires innovation, and shapes the future of young minds. And our theme remains: space is the next destination. Let's explore it together. Are you all ready? So if you're all ready, please drop your comments in the YouTube live chat. Before we move ahead, let's quickly understand what S Talks is all about. The S in the S Talks, sir, you can mute.
Yeah.
The S in the S Talk stands for Space, Aerospace, and Futuristic Technologies. This initiative is dedicated to inspiring young minds towards the exciting world of space, science, innovation, and emerging technologies. S Talks is a year-long online lecture series featuring 52 lectures, 52 speakers, 52 topics with 52 hours of knowledge and inspiration. This is not just a lecture series, it is a moment to build the next generation of scientists, engineers, innovators, and future leaders. And through this S Talks, participants get the opportunity to learn directly from top scientists and industry experts, explore career opportunities in space and defense sectors, build communication and critical thinking skills, earn participation through active participation in all our events. That sounds exciting, doesn't it? And we are yet just to get started with this event. So now, before we move any further, let's take a quick look. That was a glimpse of KIYE, a platform where young minds are guided, inspired, and given the right direction to dream bigger. And now, to share what KIYE truly means from a student's perspective, I invite one of our dedicated student coordinators, Sneha, to share her experience with KIYE. Miss Sneha, over to you.
Good evening, respected dignitaries, mentors, and my dear young leaders. I am Sneha, a student coordinator of KIYE. Thank you for giving me this valuable opportunity to share my experience. My journey with KIYE Foundation started during National Science Day event, Vignan Vaibhav 2025. I had gone there just to see what the event was about, but that one visit gradually became something meaningful for me. I was introduced to KIYE at that time through a friend, and from there I slowly started understanding its vision. I could feel that its vision is deep, connected to many people and opportunities, and something I can continue learning from over time. Of course, everyone feels it right because seeing real technology, listening to expert, that would be wonderful. And being part of such events helped many to learn and think in a better way. Same for me. Later, I attended the Kalam Space Convention as a student coordinator and also Aryabhatta Space Lectures as an audience member. These experiences encouraged me to think bigger. And today, being here at S-Talks, I feel like I am continuing my journey step by step. I would like to sincerely thank Satish Reddy sir for his guidance and inspiration. One thing I truly feel is behind every step we take here, there is always a voice that says, you can do it. And that voice is Naresh Indian sir. Thank you, sir. Thank you so much. As Dr. APJ Abdul Kalam sir said, a dream is not that which you see while sleeping. It is something that does not let you sleep. I feel KY has given me that kind of direction. If I can share one thing with everyone, it would be live a life that defines you by taking at least one step forward when you feel stuck. This is a small and meaningful journey for me, and I'm glad I took that first step. Thank you everyone. Jai Hind.
Thank you very much, Sneha. And thank you so much for your wonderful words. Your words truly reflect the spirit, passion, and purpose of KIYE. Now, let's bring in a little more energy before we move to our speaker. Everyone joining us live, if you're excited for today's session, drop a quick ready in the chat. And throughout the session, feel free to share your thoughts, questions in the YouTube live chat. We'll also be taking selected questions during the Q&A session, and at the end, let's discuss all of them with Sir. So stay active, stay curious, and stay engaged. Now comes the most awaited moment of today's session, and it's my privilege to introduce our esteemed speaker, Kiran Kuchi, professor in the Department of Electrical Engineering at Indian Institute of Technology, Hyderabad. Sir is a renowned expert in wireless communications, signal processing, and next generation 5G 6G technologies. With significant contributions in areas such as massive MIMO, IoT, and advanced wireless networks, he's also the founder and director of Wisig Networks, a pioneering startup focused on indigenous 5G and IoT solutions. Sir has played a key role in India's telecom research and global standardization efforts through the third generation partnership project and has led major national initiatives, including the indigenous 5G testbed project. With an outstanding academic and research career, Professor Kiran Kuchi sir has authored numerous high-impact research publications and also holds several patents in the field of wireless communication technologies. Under his guidance, many students and researchers have contributed to cutting-edge innovations in communication systems and emerging digital technologies. His work has greatly contributed to strengthening India's vision of self reliant and globally competitive telecom infrastructure. Known for his visionary leadership, research excellence, and dedication towards technological self reliance, Professor Kiran Kuchi sir continues to inspire students, researchers, and innovators across the country. It is truly an honor to welcome such a distinguished academician, researcher, and innovator among us today. We're truly honored to have you with us today, sir. Participants, if you're excited to hear from sir, drop a quick welcome, sir, in the chat. And now, without any further delay, sir, the virtual stage is yours. Sir, you're talking on mute.
Thank you.
Thank you, sir.
Madhurima, Sneha. I admire your enthusiasm and your contributions to the student community. This is wonderful. Welcome, my dear students. Some of you are still high school children, probably in late high school. It is my privilege to be able to spend this evening with you, although digitally. I would like to share some experiences that I have. And as you have seen from the abstract of my talk, I would like to focus on uh, some things that we all wonder about communications, because today I'm speaking to you sitting somewhere in Hyderabad through this YouTube link. And what I am speaking to you is going through so many communication media, that is including, I speak here, the computer picks it up, it goes through a fiber, then it goes to a cell tower, then it goes to a satellite, then it comes back to you in some other form. So it's really a remarkable progress. So I would like to just walk through the journey. And thankfully, we have built some such systems. I will share those experiences with you. With that, I will present some slides. Shall I bring up my presentation?
Sure, sir. We can start.
Yeah. Are you able to see the screen?
Yes, sir. Yes.
Excellent. So I have put a title from Sparks to 6G. 6G is what we are building now, and we are in the process of rolling out 5G. These are the latest wireless communication technologies. But I just want to go. I want to take several steps back, going back 200 years, where it all started, and leading to where we are. And this kind of tells you a few things. It all starts with one small idea, maybe just a spark. Okay, and that leads to what we have today: information transmission through fiber, cables, uh, wireless, even satellites. Okay, so when you press a send button, whether it's a WhatsApp message or an SMS, what really happens? Okay, you have a phone, you press a button, and this information somehow is converted into an electromagnetic wave radiated through the antenna located inside your phone. And it reaches a nearby cell tower. Another antenna picks up this information and it processes it. But then you want to send a message to a friend. They could be anywhere. The friend may be in America. The friend may be in another district or another city in India, anywhere in the world. How do you send this? The base station, how does it know where to take it? Well, it may go through a fiber from the base station cell tower to the nearest aggregation point within that city. It could be, this electromagnetic wave from the cell tower may go through a fiber, thousands of kilometers, hundreds of kilometers to thousands of kilometers. And then it may even go through a satellite, for all you know, sometimes, depending on what we are trying to do. It goes through a very complicated number of media: cables, copper cables, wires, satellites, and wireless. Finally, it reaches the destination using something called an internet protocol. So, where did it all begin? It all began with a simple observation that electric current in a wire could deflect a compass needle. So, there we have one of the clear links between electricity and magnetism. Okay, Hans Christian Ørsted in 1820. Then we have a number of scientists, very brilliant people. They have taken this simple idea and come up with the whole phenomena called electricity, magnetism, and then linking them together, electromagnetism. Okay, Faraday is more or less the father of this idea called electromagnetism, and he didn't go to school, he didn't go to college. He was working in a printing press, reading books, and doing experiments in his spare time. Okay, this simple observation that Christian Ørsted has come up with, picked up by Faraday, and it led to an entire revolution in just about 200 years. Now, let's just trace through this a little more. Okay. Um, so, before the theories of electricity, magnetism, um, electromagnetic wave theory, Maxwell's equations, before these theories were even put in place, do you know that information transmission took place even across the Atlantic between the UK and USA through a copper cable? Just imagine, we're talking about nearly 200 years ago. Engineers were able to communicate messages through telegraph lines. It could be very small messages. And there was hardly any theory of communication. There was no mathematics behind this. It was just electricity, magnetism, experiments. And a line was laid 3,200 kilometers by entrepreneurs. People put their money and laid this line. There were lines everywhere. Then people started seeing some challenges when you keep these lines across the Atlantic. Signals started attenuating. Information didn't, especially with this transatlantic line, information didn't reach. Then the scientists started analyzing this. And some of you probably are electrical engineers or, electronics, communication, you would have seen this even in high school. R, L, and C. What are they? Resistor, inductor, and capacitor. A great scientist by name Oliver Heaviside single-handedly came up with this notion of applying electromagnetic wave equations developed by Maxwell. And eventually, he came up with this notion of R, L, and C, and then started applying this for optimizing these transatlantic lines, increase the speed of communication. This is about 200 years ago. So the mathematics and the circuits came much later after the line was laid. This invented the idea of a channel. Okay, then came digital communications, the great Shannon's theory, how fast a signal can travel, how fast information can travel through a line, wireless or wired, all these things, Wi-Fi, 5G, fiber, USB, all of them, they are based on Oliver Heaviside's theory, which we call RLC. That's the foundation for circuits. So it's very interesting. The experiment, the system came first, then the mathematics came later. Okay. Then, do you know that electrical waves can travel through metals? They're called coaxial cables. That's how we wish to make telephone calls. You have Ethernet cables. Information passes through these cables, coaxial cables, copper cables, and that's the electricity, that's the magnetism, the underlying principles, and then we have a whole communication theory and the circuits that get into designing these systems. Then people have figured out you can transmit information, messages very, very fast through glass. That's called fiber optics. These fiber optics offer huge bandwidth. You can send gigabits per second, terabits per second, huge gigantic amounts of information. That's how so many billions of people are able to exchange information, because of the ability to transmit information through glass. That is fiber optics. Okay, just to give you a perspective. Now, there are, of course, four people mentioning four names is a disservice to all the scientists that came, before them and after them. But let's just start with Maxwell, who came up with the theory of EM waves, electromagnetic waves. Probably the entire information, communication, electronics, everything that we use today, rides on Maxwell's equations. I'm sure some of you might have studied them, and those who do physics, they know this electromagnetic waves. What was the inspiration for this? You know, there was no math before this, and Faraday came up with these concepts. Who didn't even go to school, and then Maxwell picked it up from him, and then came up with this whole theory out of almost nowhere. These are all thought experiments. Then Hertz proved them in the lab, the existence of electromagnetic waves. Then, do you know that somewhere in Bengal in those days, now this is Dhaka University, J.C. Bose actually built the circuits, and he used something called millimeter waves, which we use in 5G and even 6G and beyond. He built the whole system. It's not Marconi who developed the radio. It was J.C. Bose. IEEE has formally recognized that radio communication, invention, demonstration came from J.C. Bose from India. Do you know that? It's in 1895. Still, you can go and visit his lab in Dhaka University. You'll see the equipment out there. It was the undivided India at the time. Then Marconi showed how to transmit radio waves, transmit information without wires. Then Bell Canada, Bell Labs, USA, and AT&T, they pioneered this technology, and rest is history. So it all started with analog communications, that is AM, FM. Those some of you may not even know or experience these systems. AM and FM is all we had, growing up, listening to news, listening to cricket matches, commentary, all sorts of things. AM and FM broadcasting. In Second World War, radars were used, to detect, incoming unfriendly objects. That's again some form of communication and sensing. 1G, you probably don't know what it is, analog communications. 2G, GSM still around. Every 10 years, a new G came. Roughly every 20 years, a revolution took place, right from the mid-90s. Then 4G came. Today we still use 4G. Now we have 5G. Then we're moving to 6G, and we're building them. So for each generation, what happened? Better mathematics, better algorithms, better semiconductor chips, better antennas, better software, and these are global. That is, it's not done by one person or one company, or it's just global. That is starting from 3G, 4G, 5G. It is developed through a worldwide community of scientists and engineers who come up with these things. We'll talk more about that. Okay, what are standards? Okay, if every country had their own cell phone system and it is developed independently, imagine what happens. Yeah, I take a phone, I get into the airplane in Hyderabad, I land in London, the phone just doesn't work. It doesn't work in that country. Today, I take my cell phone, I go all over the world. Wherever I go, I'm able to send WhatsApp messages and make phone calls. That's because the underlying standards and the technology behind 3G, 4G, 5G, it's developed globally together, and it's a global standard. Once the global standard is written, people build products like cell phones, base stations, and things like that, phones, chips, whatever it is. So you can have these devices that work anywhere in the world. Okay. So global standards in this particular area are very important, especially in information transmission systems. Now, what is India's role in defining these global standards? Until around 2015, we actually had no skin in the game. For the first time, myself, together with a group of engineers, initially I was alone from IIT Hyderabad, and later on with some other friends from other places, universities. I took a team to meetings once a month around the world, compete with the best in the world, all the companies that contribute to these global standards: Nokia, Ericsson, Huawei, Qualcomm, NEC, Fujitsu, Docomo, I mean, name it, AT&T. All these companies, you have to compete with them, put your best ideas across the table, compete with them, fight with them, get your ideas through. And we did that. That was almost a 5-year journey. Today, the cell phones we use, networks we use, include technologies and patents IIT Hyderabad and Wisig has developed. They're part of your cell phones. The people use them, not just in India, everywhere in the world. But of course, it was a long, long journey. That was defining standards. Now we're working on 6G. We keep doing that kind of work. That is about defining standards and protocols. Then we'll talk about products. What are products? That we'll discuss in a minute. Okay. Before we talk about the product, we do research, then we convert them into products. How do you do research? In wireless communication, research is all about 3 or 4 different things. You start with the mathematics. You have physics, then you have mathematics, and you have mathematical models. It all boils down to a set of equations, concepts. You do computer simulations, then you build software, you build hardware, and you build products. Okay? So we may not be dealing with the physics every day, but the physics is always there. Then the electromagnetics, then the mathematical models, and computer simulations. Then we do product development. Today, we have developed entire 5G network equipment. What is there in the cell tower? For the first time, such a technology of that kind of complexity is built out of IIT Hyderabad and the company I founded, Wisig Networks. It is working, deployed, serving people. It is early days to scale up, but it's built out of Hyderabad, out of India. Okay? It is the most advanced communication system. Of course, we're going to build 6G next, but we're going to first commercialize this. This is one. The second, we built a chipset. What is a chipset? It is a integrated circuit, very tiny one, just about a centimeter square, less than that. It has crores of transistors built into it. It has processors. It has analog circuits, digital circuits. It enables communication from almost anywhere on earth. You'll be able to use this chip and the device, connect through satellites, and send messages across. We are launching this device through a company called Viasat very shortly. It's kind of like Starlink. You must have heard something like Starlink. So we are working with such companies. Launching this device, it can connect almost anybody, anywhere on earth, to almost anything. Okay, it's a tiny device. So that requires semiconductor technology, chip design, communication systems, whole bunch of things. So we have been able to build a very complicated chip out of IIT Hyderabad, Wisig Networks, and we're also launching that. 2 things: a 5G network, a very complex chip. 2 things are built out of India using the engineers from university who graduated from IITs and other colleges. These are people like yourself. They are not so long ago, they were going to school, they were going to college. And these are the people who build this technology, people like yourself. You can see this technology demonstrated live. You see the pictures? The NIMS hospital in Hyderabad has this 5G network, an immensely complex technology. It has beamforming. It gives you gigabits per second speed. It is wireless. It's a complete end-to-end system. Patients coming to the hospital, visitors coming to the hospital, they connect to this network using some method. Okay. We have introduced this system in a few villages, including one near Sangareddy. So this village has a school, and you can see this school. There is a TV screen. It runs for 2 hours a day. Children, 1st to 5th class, they learn the content from Telangana state, digital content offered by the state. They learn 2 hours a day. Then some pre-KG children in the village, they come join them. They watch some entertainment for an hour or so. This is put to use for education and entertainment. This school has 5G connectivity. Very advanced technology is brought to the classroom. Tomorrow, maybe we'll run AI-enabled applications for these children. Not, that's something we are going to do soon. So, how did we build this? Okay, these systems include, again, I said, antennas, radios, chipsets, software. An immense amount of software and hardware. All of it is developed in-house. Not all chipsets. Some of them may be, available chipsets, but it's a system that we built for the 5G system. Okay, so the system is not just one mathematical algorithm or one algorithm. It's an integrated system composing of many subsystems. Okay, it requires hundreds of people to work day in day out for years to put and field such a system that works, in the outdoor, high heat, dust, rain. It has to work all the time. It cannot stop. The system cannot stop working just because the temperature has crossed 40 degrees centigrade. It has to work all the time. So it is in a working condition. Now I know some of you are interested in space. I can't talk more about space and satellites, but I can tell you something about communications through space and satellites. The chip that we developed, it connects to geosynchronous orbits. It connects to LEO, and we can transmit information from any place to any place on Earth using a tiny device. I'm not talking about a project that we're going to start. I'm talking about a device that we built and it's working. So how does it work? How do information travel through such large distances? You know that a geosynchronous satellite is roughly 36,000 kilometers above Earth. Now your information, the electromagnetic wave, has to go from your device, like a cell phone, all the way. It has to travel 36,000 kilometers, picked up by an antenna in the satellite, again come back to Earth, and then traverse through so many different places. That's a complex situation, but satellites are very advanced. They have the ability to pick up these weak signals, amplify them, uh, and we have built systems to work with this setup. Again, same is the case with LEO orbits. The orbit is not as friendly as geosynchronous orbit. You have to use lots of different satellites. They come and go in LEO, and your information has to go through one satellite in 1 minute, and then after 5 minutes, another satellite comes into the view. You have to switch to that and communicate. That we made it happen. So this is possible. Today we have built systems working with these with large distances under adverse conditions. Let me just conclude. Before I close, I know that many of you are using artificial intelligence. By the way, these slides I made in about 3 hours using the contents I prescribed. I was in a car going from home to IIT Hyderabad. I spent about an hour dictating the content of what should I speak today, and AI created this presentation. I saved 6 hours of making slides. Imagine, the content is still what I gave it. It just, the rest of the work is done by AI in just few hours. So that's the power of AI. So what does AI, 5G and 6G mean in the next decade? It is very important. Pay attention. Artificial intelligence is already in your cell phone. But going forward, your cell phone will not look like what it is today. Your cell phone, the Apple, Android operating systems, they will change in next 5 years. You'll forget about them in a decade from now. You will have something called agentic AI phone. What will agentic AI will do? You just have to speak. It will sense. It takes notes. It knows your preferences. The agentic AI will not need, you don't need to type into the phone. It does most of the things autonomously. You may think like this is science fiction, but it's going to happen in a year or two, or maybe 3. When you do that, this phone has to be connected to a high-speed, reliable network continuously all the time. You may think that, oh, I have a phone, it's already connected. That's just not enough. You need super high speed, higher reliability for you to conduct your work seamlessly using AI. So what does this mean? AI needs compute, chips, communication needs compute, and also chips. These two will merge. So there will be a convergence of 5G, 6G, and AI in a single device, including sensors like cameras, voice collection, and all kinds of other sensors. You will see in 2, 3 years the phone becoming a hub of sensors. It already is, but there's going to be a lot more change coming. You know, so in this era where AI is permeating, it's almost part of our everyday life. 6G, 5G, AI will work together, and it increases the productivity. Today, I made these slides for this presentation in less than an hour or two. 2 years ago, I used to spend about half a day making slides like this. Look at the number of things I could do today. That's the productivity increase. So put it to good use. Okay. Now, what does this mean for school children and college graduates? You need to learn the math. There is no escape. You need to learn the calculus, probability, algebra. This is the language of almost everything in the world. Whether it is AI, you think that AI is just prompting, but AI is nothing but a bunch of mathematical algorithms converted into a piece of software. Communication, same thing. It's all algorithms converted into software and hardware. You have to learn the math. This is number one. Number two, curiosity and experiments. The experiments can be physical experiments, they can be thought experiments. It makes hardly any difference. Einstein did all his work using thought experiments. In fact, most of the physical experiments start out as thought experiments, but then doing things hands on will be very, very, very useful. It may be now in school, maybe in college, maybe later on. Doing hands on thing, building things will be of immense help and value. At the same time, thought experiments are also very, very, very useful, and be curious, find out how things work. And if you are curious, if you work hard, you can beat the most clever guy given enough time. Trust me. I'm not as clever as many of even you listening to this conversation, but you just have to have curiosity and work very, very hard, sustain for many years. Then good things are bound to happen. So another thing, first of all, to achieve anything, you have to first dream very, very big. Can't dream small. You have to dream big. That's all. That's where it starts. You have to dream. Then, if you keep on dreaming all your life, nothing will happen. Then you have to act on your dream. But that action can be very small. No, you start small, but then for a long many years, developing very complicated systems takes many years, decades, sometimes even a lifetime, and you will see a lot of failures. You'll have a lot of uncertainty. All this you have to go through. So this is the journey one has to go through if you really have to build something meaningful. Okay, especially the company I started, the products we build, it is extremely hard, especially doing it from India when everybody says, "Oh, this can never happen." People told me this is impossible, but you just have to keep at it. Building companies is even harder. There are other people depend on you, right? They have to work with you, years, decades. They have to work with you, so you have to guide them, you have to motivate them. Sometimes you have to create opportunities for them. So that's a different aspect altogether. Building companies, leading teams. And if you do all these things, you say whether you will get success. Well, that's not in our hands, right? Success is not in our hands. Sometimes, many stars have to align before, you see success. So success is never guaranteed. You just have to do your duty, and you may be successful, you may not be successful, but the journey is very important. So you have to prepare, you have to be very, very persistent for a long time. And it's just teams that really achieve things. It's not me or one person. It's just large teams that really achieve anything great. So I will conclude my talk. Stay curious, develop your knowledge, work hard. And when you grow up, you know, if you can build teams, build products, that's what is required to build India. Thank you. We'll take some questions.
Yeah, sir. Thank you so much, sir, for that insightful and inspiring session. Your words have given us a deeper understanding of the real world applications of aerospace and defense technologies. And your journey has truly inspired us to think bigger and aim higher. Now, guys, let's move on to the Q&A session. So, all the students, please post your questions in the YouTube live chat. Sir, we have a few questions from our students. So, shall we proceed with the questions?
Yes, yes. Thank you.
Thank you, sir. Thank you. So, this is a question from Jashwant. What are the biggest technical challenges researchers currently face in 6G technology?
You know, uh, 6G is a technology that comes after 5G, and still we're trying to optimize 5G. But in 6G, what happens is that you have to improve the existing state of the art by maybe 2 times, 3 times, sometimes 10 times. So usually improving anything by a factor of 2 is very, very, very hard in technologies like 3G, 4G, 5G, 6G. And improving anything by a factor of 10 is even harder. Okay. So the researchers have to find ways to improve the state of the art by a factor 2, 3, even up to 10. And that requires a lot of hard work, especially, for example, you have cell towers communicating in, let's say, 3.5 gigahertz, giving you 1 gigabit per second. Now, if you have to expand this to 10 gigabit per second, or if you have to do this at 7 gigahertz, the challenges are numerous. The electromagnetic waves at higher frequencies don't propagate through the trees and buildings. So you have to build whole lot of new techniques to increase the speed of communication, better hardware, better software, bigger antennas, and you have to deliver all of them to the people, with almost, okay.
Sir, your voice is actually breaking. I think it's fine now.
Yeah.
Yeah. Yes, sir, it's good now.
What's the next question?
Um, there are many questions. Thank you, students. But keeping time, let's just go to few important topics which sir has not covered. So, what are the languages which they should focus to learn something about 5G and 6G technologies in current generation?
You mean
Which
languages meaning
which
computer languages?
yeah, sir. Which programming languages should they focus on to have a good foundation for the current technology?
You know, uh, students, there is no such thing as programming languages anymore. You must understand that. So what you have to focus on is the algorithms, the flowchart, the prescription of the programming you want to do. You have to come up with those principles and ideas, and you dictate like I am speaking to an artificial agent, artificial intelligence machine. It gives you the program. This is real. So this is happening all the time. So there won't be anything called a program or a language anymore. That is why I'm saying it's very, very important. Listen to me very carefully. Your math, your physics, your intuition is what will get you a job 5 years from now, 10 years from now. Your C programming or any other programming will not get you a job. Mark my words, there's no such thing as programming anymore. It is just your math, your physics, your knowledge is what will take you from where we are into your next job or whatever you want to do. It is the math, physics, and science and deeper engineering. The principles, the first principles is what will get you a job or anything else. You can do programming, you can do anything, but that will be done by AI. It is already happening.
Thank you, sir. So there's another interesting question from Sai. So, what role are institutions like IIT Hyderabad and organizations like Wisig playing in deep tech innovation?
I have already explained at length. You can see IIT Hyderabad has two or three things it does. First, we offer BTech, but that's only a part of the job professors do. What do professors do in IIT Hyderabad? They do research. They spend all their time with MTech and PhDs and their projects. They are doing research all the time. Teaching is, of course, we do, but that's a small portion of what we do. Professors spend all their time doing research. So they enhance the state of the art. That is what IIT does. IIT also creates an opportunity for students and professors to create companies. You transform your ideas into companies. That's what I did with Wisig. We created a company. We transformed our ideas and our research into a commercial product. So, in fact, places like IIT Hyderabad and similar places, they pretty much let you do whatever you want to do. Nobody tells you, nobody is there to stop you. In fact, the job of a professor or the professorship is probably one of the coolest job in the world. Nobody tells you what to do. You have to define your job. So this lets you to enable, teaching, research, excel in whatever you choose to do. Start companies or so. This is what IIT does, and companies like Wisig, they transform ideas into products. Okay.
Thank you, sir. So we have another question from our student coordinator. So I request Hasini to ask your question directly to sir.
Good evening, sir. I'm Hasini, a student coordinator of KIYE. Sir, if you are mentoring a student startup, you focused on smart agriculture using AI and IoT technologies, what would be the key elements and suggestions and the message you would like to give the students to improve and build the innovation society for tomorrow?
So if you want to use AI and IoT in agricultural field, what you probably have to do is you have to be in the field all the time, number one, and learn to work with the farmers and find out the difficulties. One of the most difficult things in this world for any product, for especially science and technology, cutting edge technology, it's very hard to penetrate into agriculture and healthcare. These are the two places the barrier to entry is very, very, very high because they have been used to decades of practices and people don't like to change the way things are done. Number one, right? Number two, they have very little money. You are trying to make money as a creating a product from a farmer who is already poor. Okay. These are the two primary considerations. That doesn't mean you shouldn't do it. What you should do is consider these two aspects. Okay. Always work with the government agencies or funding agencies, get money from them. Don't spend your own money all the time. And third, you have to be in the field trying to improve the productivity of the farm, right? Prove it in the field and find a way to make the farmer adopt this technology. So I can connect you with some people doing similar things, okay, in offline. But this is the hardest field to enter and break in. Okay, one of the hardest, especially in India, not in US, not in Israel. In Israel, they do smart farming.
Yes, sir.
They have technology and they adopt it. And in a place where there is almost no rain and arid land, they're able to cultivate. And it's a need for them. India, we have a similar situation, but we have to deal with a lot of other challenges. But it's a noble cause if you are attempting to do this. But we can discuss after.
Thank you, sir.
Thank you, Hasini. Thank you, sir. We also have another question from another student coordinator, Sneha. So, Sneha, over to you.
Hi sir, I'm Sneha, an ECE student, recently done with my third year. So before asking my question, I would like to say that I truly admire how you manage your time, sir, contributing to 200 patents and a company and still making efforts to guide students like us through sessions like this. We are very thankful for you, sir. So I would like to know what excites you the most about Beyond 60 Research or 60 Research, sir.
So two or three things. Thank you. See, I actually work. I People tell me I work. I don't sleep. They think many people ask me, "Do you ever sleep?" But actually, I sleep more than almost any one of you in this in this meeting. I have plenty of sleep. In fact, you have to sleep very much to be able to be creative. Second thing is, I actually spend a lot of time doing thought experiments. If you are spending all the time in a lab or doing design reviews, there's no time for creativity. So I actually reserve half my time just doing thought experiments. Then the rest of the time you spend time with people, students or engineers or anybody else. So this is actually very important. You have to actually take a step back and create a lot of time for yourself. This is really important if you really want to make very deep impact. So at least as far as I'm concerned, I really like to spend a lot of time thinking about things, and that's one. Next thing is, what makes you excited? See, I've always been curious about things, and I have always, I have converted the opportunities I've got into doing research. And for many years, I was an engineer and a researcher doing mathematics, computer simulations. In fact, until 2015, I never built anything myself. So only I started building things in the last, I would say, 10 years. So maybe I should have started early, but it's good. I was doing theory and computer simulations and experiments, but I was also doing a lot of research. But last 10 years, I've been building things. Actually, it's not me who build things. It is my colleagues who build things. I only enable them to build things, but I say I build things because when they do something, then I take the credit. Of course, it is them who does the real stuff. So it excites me to see the science, the mathematics, actually becoming something that you use physically on a daily basis. That creates a lot of excitement. That's number one. Number two, you're creating jobs. You're creating jobs. You're creating wealth when you run a company. Okay. Of course, if you're successful, there is wealth. If you're not successful, there's no wealth. But doesn't matter. If you may fail, that's okay. But creating jobs, creating wealth is what takes the country forward. That excites me more than anything else.
Great to listen, sir. Thank you so much.
Thank you, sir. We keeping time in mind. I'm so sorry for all of you who have we really got massive response. We have so many questions, but sir has almost covered all the topics. So we just have one last question for sir. So all of them are interesting. Okay, let me pick one. So, what skills do companies expect from ECE students who want to work in 5G or semiconductor industries?
ECE students need three things. Your math 1, 2, 3 has to be really good. I don't know what you call it, math 1, 2, 3. Your physics and chemistry, you can live with it because ECE doesn't deal with a lot of physics. Your electromagnetics better be good. Your antenna theory better be good. Okay. If your circuits knowledge, if you master RLC circuits, if you master Fourier transform, you already have a job. If you do Fourier transforms and RLC circuits, I'll give you a job if you answer three questions. Then you can do the rest of things, analog circuits, digital circuits. It goes on and on. You have to be very good, the basics of year 1 and 2. If you are good at year 1 and 2, year 3 and 4 is just a piece of cake. You'll get a job. The basics. Okay. and learn, MATLAB, Python, but you have to do real experiments with it. Okay, you have to do experiments with that language, that those mathematical tools. You have a job.
Thank you, sir. Thank you for patiently answering all of our questions. And I would like to share one thing, one memory that I have seen from one of your videos earlier. So, no amount of work is never small. As you said, today it took 2 hours for you, and a few months ago it took half a day for you. And 20 years is definitely not a small thing, where it all started in Dallas, where that from that point wherein you started to lay bricks, and one after one today we are here and to witness your success, your journey, wherein now today you're a founder and director of a great pioneering startup like Wisig signaling organization, wherein you're able to guide students, start your own innovative technological ways, wherein you're able to contribute a lot to our Indian young minds, and also you're even contributing at the global level. So we are truly honored to having you here and to witness your wonderful speech, and your inputs will definitely utilize them in our day-to-day lives, and we'll definitely keep all of your words in our minds, and we'll try to learn a lot from you, sir. Thank you so much. So, participants, I would even like to thank all of you for your wonderful participation, for your enthusiasm, and for all the active participation that you have shown towards our session today. So, coming to the close of this wonderful session, I would now like to invite Ms. Hasini to deliver the vote of thanks. Hasini, over to you.
Good evening, everyone. On behalf of KIYE Foundation, I would like to express my sincere gratitude to Dr. Kiran Kuchi sir for today's wonderful and inspiring session. From sparks to 6G, how physics became your phone and what comes next. Sir, your lecture helped us to understand how science and physics involves in today's advanced communication technology like wireless networks, 5G, 6G, and satellite communication. You explained complex topics in very simple manner and interesting, which made in every simple session engaging, easy for everyone to understand. Your journey, research, contributions towards indigenous technology development truly inspired all the students and participants here today, sir. The message you shared, learn deeply, work patiently, and dream big, is something really we always remember. Thank you, sir, for taking your valuable time and to guide and motivate us. We're truly grateful to have you here, sir. We are truly have to have grateful here, sir. I would like to thank the KIYE entire team for organizing such a beautiful event and the participants who have been joined here. Your support and the participation made this event successful. Finally, thank you to everyone for being a part of this lecture. Wonderful S-Talk session. We hope to continue learning, growing together through many more such inspiring lectures in the future. Thank you. Have a great evening ahead. Jai Hind.
Thank you.
Thank you. Thank you, Hasini, for your wonderful words. So, we would be truly delighted to have many more such sessions with you in the future, sir. And I would like to, with your permission, would like to invite you in our further future events wherein you can address, and students will get a great opportunity to hear from you at a larger platform. We usually conduct events wherein BTech graduates, students from different colleges, institutions come together, and great people like you come teach us something, and give us a lifetime memory, where that will be a great foundation for our future. And we hope that will be really helpful for all the students who are going to join us in the future events as well. So thanks a lot, sir. Thanks for your valuable and precious time.
Thank you.
And to everyone who joined us today, let us stay connected, stay curious, and keep learning. Because truly, space is the next destination. Let's explore it together. And I personally would like to thank Mr. Nareshandran Garu for being able to organize such sessions, such events, and to fill that connecting bridge between students and industry experts like Kiran Kuchi sir. So thank you very much, Nareshandran Garu. So Space is the next destination. Let's explore it together. So I hope you all had a great session this evening. Thank you everyone for joining us. Have a wonderful evening. Jai Hind.